Okay, this video is going to review interactions for you. Now, in the overheads, I'm in the overheads document right here, we cover all of the possible outcomes for a simple 2x2 factorial in order to illustrate interactions. So in this video, I'm not going to repeat what's in here. We go over this in class. I'm assuming that you can read and understand the various examples. I'm just going to point out a couple of key things that are not easy to describe in text and easier to see in a picture. But the idea here is we want to look at our graph for when the lines are not parallel. When they're not parallel, that tells us that the pattern is not the same across our independent variables. So you can see here that we have one pattern, right? The box is greater than the black circle, but the reverse pattern is true over here. So the pattern changed. When the pattern changed, that tells you that you have an interaction, or at least it's a sign of an interaction. That's not the only kind of interaction that we could have. You could have multiple types of interactions, which these overheads take you through all of the possible types. But the first one would consider each of the possible outcomes where you have no interactions. The lines are actually on top of one another, so they're parallel, so that wouldn't be an interaction. Lines are parallel, so no interaction. Two main effects here, but the lines are parallel, so no interaction. Then you consider a situation where you have no main effects but an interaction, the example that we saw a second ago. Here you can see the lines are not parallel. That would indicate that there's an interaction, and the yellow highlights tell you what is actually significant. Down here in these bar graphs, you see it represented as a bar graph. Also, it's easier to see as a line graph, but you can see it also as a bar graph. And then you see the actual hypothetical means that we're using here in this example, so you can get a sense of what the actual means are. Here's another example of a different kind of interaction. I call this the alligator interaction because it looks like a mouth of an alligator here, right? And the point of this is the interactions tell us that our IVs are combining together to produce a unique effect. And what you would have to do is, if you had these kinds of things, is explore them in a way that's logical in your post-hoc test. So the overall ANOVA is going to tell you that there's an interaction. Then you would want to look at your data in the graph and do the comparisons that make sense. For example, if you had this kind of interaction, you would want to compare these two individual groups in some form of post-hoc test, like a t-test. You expect that they're going to differ, and then you'd want to compare these two and like a t-test and show that they're not different, right? And if you have done that, then you've sort of explained the interaction. If you have a different kind of interaction, like in this one, depends on what kind of story you want to tell. In this case, you might compare this group to this group and expect them not to differ to show that it's sort of unchanging across this. And then you can compare this one to this one and show that they're changing. That paints a different picture. Now, of course, you could also do the two comparisons that we did earlier to explain this interaction. That works as well. It's just a different way of presenting the data. It's kind of like the glass half full, glass half empty kind of thing. But you would want to pick one of those approaches and sort of explain it. And it's going to depend on what your predictions were, what your study is, and also sort of what you see. So that's the idea behind this. Go through this outline, read it carefully, and practice detecting the interactions to sort of see what kind of an effect the IVs had on the DV.